first thing in our system is a step-down transformer, which then goes into an isolating transformer, which is there for safety. And then we have our voltage generation terminal, 10-kilometer transmission line model, our first load terminal, and then another 10-kilometer transmission line, and then our second load terminal. And so altogether this forms a radial multi-terminal DC system. So looking at the individual components, we start off with a rectifier. This is a voltage source converter with IGBTs powered by this power supply, and this is in the rectification mode. Then we have our DC link capacitor and these inductors and this resistor. These resistors model a transmission line of 10 kilometers. And then we have our first load terminal, another 10-kilometer transmission line, and then another DC link capacitor into our inverter. And this is controlled by this controller, sending signals to control the IGBTs of the inverter, which is powered by this power supply here. On the AC side, we have these filter inductors and then our load resistor, which we have set to a value to match our filter. And the second terminal over here, which is another load terminal, is exactly the same as this terminal here. So the first fault we're simulating is just before terminal 2, which is in zone 1. We have our fault resistance of 1.5 ohms connected across here. This is a pole-to-pole fault, and we can simulate this fault by flipping the switch to short through the resistor, and then we are measuring it on the oscilloscope, as David said before. So first we have the zone 1 current, which is positive, and then you'll notice that the zone 2 current is negative because the DC link capacitor from zone 2 is going back into zone 1 because that is where the short circuit is. And then you'll notice that the AC current for both terminal 2 and terminal 3 loads is reduced because all the power is now going into the fault short circuit. So now we've moved our fault to zone 2, which is just before terminal 3, and you can see that with our new measurements both spikes are positive. This is because the current is going through both current meters towards zone 2 and towards the fault.